And let's do concept of resolution of vectors before we now do the resolution of vector. So now, if I have a line like this is horizontal line. If I have a line like this is vertical line. Now to vector, so if I have a vector like this vertically and also horizontally, remember these two vectors are at 90 degrees to each other. So now let's say this is their resultant, and let's say this is theta. No, now if you look at this theta is to the horizontal. That is, I have horizontal line, my resultant. So see the theta is touching the horizontal. Take note. So if the theta is to the horizontal, then look at this. If I have here to be alpha, then this alpha is to the vertical. That is touching the vertical. So if I mention in a question and I say the angle is to the horizontal, you should know that it's touching the horizontal. So if I say it's to the vertical, you should know that it's touching the vertical. So take note of those points. Now in this case, what is this place, this vertical, and what is this horizontal? So let's go by normal calculation, that is using Pythagoras theorem. But to see it clearly, remember I said vectors are movable. Now let me assume that I move this vector here. So let me move it here to this place so you can see clearly what we are about to do. So vectors are movable. So if I move it, do you see it has formed right angle triangle? Remember the diagram is like this before. The diagram is like this before. So then I move this. Vectors are movable. I just move it like this to this place. So by moving it, it has formed a right angle triangle. Take note. So now from that right angle triangle, I can find this place. So if I label A, B, C, so I can find AB and BC. So now what is AB? Do you know, according to your right angle triangle, this place is opposite, this is hypotenuse, why this is adjacent, where the two sits. Now we'll use SOHCAHTOA. So we are using SOHCAHTOA. So now what is BC? You know, that is opposite, and hypotenuse is R. So far I know my hypotenuse. That means sine theta equals opposite, that is BC, over hypotenuse, that is R. So BC is equals to R sine theta. That means this place opposite is R sine theta. Now let's find the adjacent also. So I'll use cos theta, that is SOHCAHTOA, means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So that means cos theta is adjacent over hypotenuse. So that means cos theta. So what is adjacent? That is AB, that is divided by R. So AB is R cos theta. That means we have known this place now. That is R cos theta. So here is R cos theta. So now if you combine everything now, so let me now show you what we are doing here. Okay, so if this hypotenuse is R, then the vertical is R sin theta, while the horizontal is R cos theta. So in physics term, we now say the vertical component of this vector is R sin theta, while the horizontal component is R cos theta. Now see the tip and point of what I want you to take note now. You see that this theta is touching the horizontal. So if anywhere the theta is touching or the angle is touching, is always cos. So the other side, which is the other side vertical here, will now be sine. So it is not that horizontal is always cos, it is where the theta lies that is always cos. The other side will be sine. That means anytime you see this in scalar and vector, you don't actually need to start using SOHCAHTOA every time. So just know these techniques like that. So don't be doing SOHCAHTOA every time. To take your time. Now let's test ourselves on this. So let's say I have a vector like this. Let's say I have a vector. If this place is 20 Newton and this place is 10 Newton, 10 degree. So here is 10 degree and here is 20 Newton. Now, what is the vertical component? If we say vertical component, you know vertical is straight, horizontal is like this. Take note. So this is vertical, while this is horizontal. Now, what is the vertical component and what is the horizontal component? Yeah. Now, first thing is that you don't need to start using SOHCAHTOA. Where does the angle lies? You will see the angle lies to the horizontal, as in like this. So the angle is touching this is vertical. The angle is not touching the vertical, it's touching the horizontal. So that means this horizontal is cos. Then this is 20 cos 10. So this place will now be 20 sine 10. Please take note, you don't need to be using SOHCAHTOA every time. We are not solving now, we are just doing the concept. So let me see another one. Let's say my diagram is like this. Here is R. Let's say here is 20 Newton. Here is 50 degree, like this. So now remember, total angle here is 90. So if that place is 50, definitely here must be 40. That is 50, 90 minus 50, 40, because total angle here must be 90. Now I'm doing this so that we will now see the angles we are using. Now let's say you have a question like this and I'll say what is the vertical component, that is I'm asking for this place, and horizontal component I'm asking for this place of these vectors above. Now if you and your friend want to solve this, if you decide to choose 50 degree as your own angle, now if you decide to choose 50 degree, now where does the 50 degree lies? The 50 degree, let me sketch it, you see is touching the vertical. So the 50 is touching the vertical. That means where that 50 is touching is cos. That means this place is cos. Then here must be 20 cos theta. That means the vertical is 20 cos 50, like that. So anywhere that angle touch, please take note, is cos. So that means that place is 20 cos 50. So the other one will be sine. Why this place will be 20 sine 50, like that. So anywhere the angle lies is always cos. Take note. Now if your friend now choose that, okay, I'm not using 50, I want to use 40. Now so far you are now using 40. Where does the 40 lies? You will see the 40 is touching the horizontal. Then is that place that will be cos. Then for this case, this will be 20 cos 40, as in because 40 is to the horizontal, where that angle lies is cos. Why this place will now be 20 sine 40. So any angle you use, you will get the same answer. Just note that the angle you are using, anywhere it's touched, is cos. The other side will be sine, so that you will not be doing SOHCAHTOA every time in vectors. So now if you press calculator for these two, then it must give you the same result. So 20 cos 15 will give you, if you press calculator, 12.86 approximately. And 20 sine 14, if you press, it's still the same result. So like that. So 20 cos 14 will give you 15.3. So this will give you 15.32. Why 20 sine 14? 20 sine 40 will still give you 20 sine 50 rather will still give you 15.32. So you notice that the answer must be the same. Take note, it's where the angle lies that will be cos, the other side will be sine. We are not solving, this is concept. Now let's say I have this, then here is 70 Newton. Now what is the horizontal and vertical component of this vector above? So if you look at this vector now, where does the angle touch? The angle is touching the horizontal. So that horizontal will be cos. Then here will be 70 cos 60. While here will be 70 sine 60. So one will be cos, the other will be sine. So everything depends on your angle. The angle will determine where will be cos or sine. Anywhere your angle is touching is cos. Now if I say here is 30, then is this place that must be cos. If I'm using 30, then here will be 70 cos 30, as in the other one will be 70 sine 30. Where the angle lies is always cos. You see, I'm just emphasizing on this because students, you forget things easily, and in school most of the time they give you impression that cos is always horizontal, is always cos. No, it is where the angle lies that is cos. Instead of using Pythagoras theorem every time, so you can just learn that concept. So now let's say I have something like this, 10 Newton, 50 degree. Yeah, look at this now. Which one is cos, which one is sine? Now according to this, the 50 is touching the vertical, so that vertical must be cos. So here is 10 cos 50, while here will be 10 sine 50. So where your angle touch is always cos, to avoid long expression using Pythagoras every time. So now that is it. So we can now move on in the next to the next aspect of this. But before that, let's say I move this vector. Yeah, if you move it and move it to this place, then it will form right angle. So by using SOHCAHTOA, so you will later notice this is opposite and this is hypotenuse. So and this is opposite, this is adjacent. So this is hypotenuse, this is opposite. So if you want to find this place, that will be adjacent over hypotenuse, and that is cos. So that means we don't actually need to be passing through SOHCAHTOA. So just know anywhere the angle touch is cos, the other one is sine, like that. So another thing we need to know is the sign convention for vectors. So sign convention. So here, any force facing up is plus, any force facing down is minus, any excuse me so any force facing up, let me quickly change the board task. So any force facing up is plus, anyone facing down is minus. Right is plus, then left is minus. So that if you are doing resolution in the next one we are going, so I will explain this better, this plus or sign and everything. So now according to what I have explained, resolve, tell me all this, that is where will be cos and where will be sine. 50 degree, 10 Newton. So resolve everything here into horizontal and vertical. So resolve everything. You can show me the solution in comment box. So, or if you understand, just say you understand. So now just resolve all this into horizontal and vertical based on what I have explained. So we have different forces now. Resolve them into horizontal and vertical. Where will be cos? Where will be sine? So do it. So you don't need to cram anything. Anywhere the angle touch is always cos. The other one is sine. So we'll move on in the next video to calculations now. Resolution.